29th of January 26th. Here we are. It's cold here in Oakville, Ontario. I think it's like minus 20 or something. So, and it's
Ew.
yeah, it's definitely like our friends in Arizona. It's much colder. Hey Rob, how's it going?
Great, great, great. Busy days. You head out when on Saturday, is it?
Yeah, Saturday evening. So yeah, heading to Bangalore via Munich. I decided to skip Dubai this time. A story for another time on that. But the crew in Dubai are awesome. I just have some visa issues that make it difficult to fly through there. But
Yes.
that we'll save that for a later story. Oh,
Great. Well, you're in Bangalore. Go ahead.
yeah. We also invited Mark Allen. I think I see on the call. Hey Mark, if you're there.
Hey everyone. Yeah, I'm balancing out your weather. So we in Puerto Rico
Uh,
for a retreat last weekend and trying to head back to Vermont, and the airports were closed. A forced couple of nights in
uh,
Miami, so
Mark,
not so bad a
you're
place to have to be. So I'm balancing out your temperature.
breaking up a little bit. I think you're on a wireless or something, but only got about half of that. But you're in Miami, huh?
I will be. Yeah, yeah, I'll be in front of my desk in about 2 minutes. Just
All right. Well,
yeah. Can you hear me all right?
yeah, you're breaking up a little bit, but we'll check in with you
Okay.
when you're at your desk at a faster speed, and we'll go through the Agentics. I'm not even sure what we're calling this. The retreat here in Vermont in a few minutes here. Yeah, it's lots
Nice.
and lots going on here today. I guess the news this week has been the idea of the I guess what are we calling it now? Molten bot,
Well, what?
chowder bot. I'm going to call mine chowder bot.
I'm just
But
waiting for the wave of horror stories to come in from folks on,
well,
you know.
it's not okay. Here's the problem. They didn't include any defense system. Like when you look at the core of what they built, or what I don't even know who it is, but whoever built it, the core is actually not bad. Like it's not inherently unsafe. What is inherently unsafe is if you run it without any kind of sort of safety guards, which us in the world of AI, we've been doing for a while at
Yeah.
this point. And you guys might remember the what I call it. My AI defense system that I built a while back. Now that's the point, right, of these sorts of systems, right? So I've got the AI defense. I did an update the other day, by the way. So the AI defense system basically will obfuscate security. It looks for it, all the things we like to do. It looks at itself and says, how am I going to be exploited? And then it does that really fast, and then it doesn't allow it to sort of go off the rails and do things that aren't supposed to. So it creates a bounded execution, right? You can work within the confines of this, and if you don't, I will detect it and stop you from doing it, basically, right? So this with the Molten bot, I guess, would solve all their security issues, right? So easy, it works, it does all the things you want, it's secure, right? That kind of thing. Learns, it gets better as it goes. It's hacking itself. Now, what I ended up doing, because I like to build, and this by the way still needs some work. I guess I got a few downloads already, but it still needs some work. But basically, I created a clone of the thing verbatim. I'm not ready to demo it just yet. I don't. I'm going to do a different demo. Maybe I will demo it. I don't know. I gotta get. I'll come back to this, I think. But basically, it allows you to run in essence Claude Flow in the sort of I don't know. I guess like AWS is that. I guess that's what they're doing, and it just kind of runs itself. This is basically agentic flow. Right. This runs independently of Claude. Same idea. I guess mine are too nerdy or something to go viral. I built this ages ago. I, I, this, I guess it was narrow enough that people were like, oh, this makes sense. I can get agents to do things. And we're like, yeah, that's the whole point of agents, guys. But yeah, that's interesting times there. It certainly has made the rounds. I've seen articles there about it everywhere. So good for them. What else is going on? What do we need to cover here? I'm sure there's a bunch of things we need to cover. I'm waiting for Mark to come back, and I'll give you guys a little sneak peek of the site. Yeah.
Nice. Budapest is set for February 25th. And that's Tomas. So that chapter will be holding its first event. Let's see. Tech Week was announced for May 25th as well. There's skills are exploding. Skills and plugins and capability sets. And there's so many neat projects that are going on. As Barry is here, he's got a bunch of stuff in the works as well. That's it's a really interesting angle. Conceptual packaging of sort of breaks out a whole bunch of the components that were being nested into agents. It's fascinating.
Well, yeah, and by the way, those skills are prompt injections, basically, right?
Yeah,
So
that's right.
the be careful with them. And once you like, for example, if you're using skills.sh, I think from Vercel, you're basically downloading 3,500 random skills that random people have built to do random things. Like install MCP, do this, do that when you're not looking. And you're not even looking at half the shit that Claude is even doing. So all of a sudden you've got a backdoor into your system because you randomly decided to. Now, that could be said about me and all the damn skills I give you guys as well. But the core difference, if there is one, is the fact that I'm showing you my code. You're going there and deciding to do and use that. But similarly, I'm basically doing a prompt injection every time you use one of my skills. I guess I just put myself out there in a way that hopefully is a little bit more transparent than others.
Definitely have to be vetted. Yes. Before you integrate.
Yeah.
That's right.
But back to AI
kind of,
defense. Oh,
I was
sorry.
going to say, it's kind of funny that, obviously what they built was an appliance, but, and they were quite clear, run this on its own machine. But there were at least one influencer I could name who said, "Oh, I just installed this on my main machine," and my head went, "You are actually a leading influencer when it comes to AI. I can name him if you want." And the notion that you would run something when you have talked about AIs escaping their boundaries, and you don't know where this code came from.
Well, embarrassed guys, like how many of us have run like Claude straight up, or Claude Flow, or some variant of that directly on your computer, and didn't have two sort of thoughts about doing that. Now, the only difference is he and his tool are where we were 8 or 9 months ago, right? So he's newer in the evolution in what he's built. You can tell it's fairly rudimentary. So for a lot of people, they're experiencing this thing for the first time. But like, how many people, like hundreds of thousands at this point, have downloaded Claude Flow, and they're just installing it on their Macs or Windows at this point. They're not using. I'm telling you guys to use Docker and use code spaces, but I know like the vast majority aren't.
Right. Well, okay. So, but this was an AI influencer who, I really respect what he says about models and all the rest of it. And then he said, "Oh, I installed this on my Mac."
Well, is he like what is he influencing? Is he building stuff, or is he sharing stuff? Nothing wrong with sharing.
He's not building stuff, but he does talk about safety of models.
Mm-hmm.
He's a journalist then.
Yeah, it's easy to talk. That's
Yeah.
And I'm not just I don't want to say that necessarily this guy is wrong or whatever in what he has to say. And there's a lot of thinking that can happen that's valuable as well. But there's something you get by doing.
For sure. I mean, I never run anything locally. I'm cautious. Like I was in the market anyway to buy a machine. And that pushed me over the edge. It hasn't arrived yet. I'm going to buy a powerful M4 Mac. But the notion that I'm cautious about whether I'd let that run on my main network. I'm thinking, okay, I'm going to partition it. I'm going to stick it outside the DMZ.
Well, I got you guys beat. I've created a system that essentially, well, I'm gonna see. I can share two screens at once. Let's do that. So I'm sharing my Mac and my Windows system at the same time here. And I've created an app that basically optimizes the core. And Peter mentioned this before. It's like, do you trust it? This is the topic du jour. And I'm glad you guys are thinking about this. I bought this Mac exists for me to hack. That's the only reason I have it. So I don't really care. I build things with it. But in this case, if I'm gonna do like and optimize all my apps, so you can see here I've got 6 apps, and I've cranked this up even further on Windows. So Windows, I've got that, so I can go here and I can optimize it as well, and I get different settings and different options. Now the optimized browser, this is basically in the running in the background. I've got the MinCut algo running and trying to sort of understand how the CPU and resources are sort of running, and then I optimize it. So in the top right hand corner, you'll see here I've saved 11 gigs looks like. But what we're going to do today, I'm going to get back to this in a minute, but what we're going to do today is look at my control center. So if you've ever used PowerToys on Windows, this is PowerToys on crack. So I'm going to show you how I'm building this, ADRs, everything. What I've done is I've infused RuVector into the core of both OS X and no, sorry, OS X. How old am I? OS and Mac OS and the Windows. So this is basically running in the core part of the kernel of Windows. Now and I don't want to say it's a virus, but it certainly has tentacles in everything. Now the question is, would you run this? I don't know. It took my 10-year-old Mac and made it run almost as fast as a brand new Mac that I have by basically hyper optimizing the internal workings of the operating system and learning and adapting and adjusting to all the information that sits within it. And then and the last piece I'm going to do, I'll show you guys, is I've got an agentic system that can control all the core applications of your operating system from the sort of hardware all up to like Photoshop or Word or whatever, all running and doing. Here, let me show you the one graphic quick. And I go in here, oops, and of course it's having trouble because I'm doing Zoom. I probably have too much stuff open. Let me stop sharing so many screens. One sec, guys. Anyway, I'm going to come back to that. But Jed, how's it going?
Uh, it's been a wild few. Has it only been days? It's been a wild few, however long it's been, with the explosion of Moltbot now, I think is what it's called. I've been going through and seeing whose sessions were exposed publicly just to see how many potential victims there will be. And I've already been able to detect about 800, 900 exposed sessions. I'm sure there are many hundreds more. So I figure it's only a matter of time before its creator starts landing in hot water, and hopefully they've already thought about that. In the meantime,
Yeah,
I
hot water is an understatement.
well, it's certainly not
Uh,
cold.
yeah.
So in the meantime, I have my own instance running in an incredibly secured, locked down, remote server, just to see what it can do and what it's trying to do and what's also trying to do stuff to it. I received on the order of 6 or 7 thousand inbound requests to that IP address trying to hit the public port of that uh, Moltbot instance over the course of a day and a half. So I
Now,
imagine someone else who is much more nefarious than I am is already looking to exploit this.
well, you can defend it with AI defense pretty easily. One of the things I would say is if you look at like just Lovable, or you look at like just about any of these Claude sort of environments, the internet is awash with this. This brings attention to it, but it's not exactly novel to this particular project. Um,
Oh,
it's
I
we
agree.
we're it's good people are thinking and talking about it though, right? It can't hurt.
I don't know if we've reached that critical mass yet.
No, we're in a early. We're the early adopters for sure,
My
and
trouble with
we're
the people who were calling this a security failure is that they don't offer solutions. They only talk about the problem.
No, we
So
offer a solution.
Can we give them a pull
Yeah,
request? and get some-
I just showed you guys. I just showed you guys the solution. AI
Well,
defense.
seeing as these are publicly accessible, how hard would it be, Rube, to inject AI defense over it?
Yeah, but so illegal. First of all, I wouldn't do that. But that aside, easy. So remember the idea of defense and offense are flip sides of the same coin, right? So when I'm bragging about the fact that AI defense can sort of hack itself to understand itself, to learn about itself, to protect itself, that is semantically the same as pointing it at something else, right? And that's the challenge we have with any of these systems. So in some ways, this might be, the most powerful sort of defensive system for agentics, but it potentially is the most powerful for, exploitation. So we have to be very careful on this technology. So the reason I focused it on defense is for obvious reasons. I'm not a bad guy. I don't want these things being used in bad ways. But the problem is there's a lot of bad people out there that could probably see the inverse of anything. So we're in a strange time for sure.
Moltbot
is
marketplace, right? So how hard would it be to prepare AI defense to join that marketplace so those who are at the very least aware and willing can adopt it?
What marketplace are you talking about?
the Moltbot, you're saying?
There you go. Yeah.
So Moltbot is an MIT licensed open source project. So you can just create a fork of it with security, right?
I didn't just fork it because it was kind of garbage, but I rebuilt it from the ground up, and that's what RuveBot does. So
Okay.
it's well, that's RuveVector, wrong one, yeah, to RuveBot. I haven't released it yet. Well, I've released it, but I haven't done the post on it. But yeah, that's so this system is verbatim. So I use the same general API syntax. I secured it, just to be clear, and then I added a bunch of features that it didn't have, right? So then I added the ability to do real-time prompt injection. So before the request ever leaves, you can detect it. I added my AI defense system. I've included the PII protection, so it does real-time sort of extraction of anything personally identifiable. Now, keep in mind, I'm not using an LLM to actually do any of this, right? So what I'm not doing is saying, hey, Claude, where's the personal identifiable information? Which would be stupid, just as an FYI. I'm using a secondary internal system that basically understands the structure, right? And learns and adapts, vector, all that kind of stuff, right? And I'm using local embedding. So the data, the embeddings is one of those oversights that a lot of people don't look at when they're securing their infrastructure. Like I put in this Llama Guard thing and it protects my LLM from being exploited, yet I'm using these random embedding API services I found on Hugging Face, which makes no sense, right? Because that's obviously the most core part of where you're getting your information, understanding your information is going to come from an embedding model. So it's actually the easiest point of exploitation. I can literally put an embedding model on Hugging Face, make it super optimized for some random thing that has valuable sort of information like a medical device. And then people with their Claude go and say, oh, there's a low cost or free embedding model, right? So you have to be very careful with the external embedding models, because once you've defined the data, you own the system. Learning, multi-tenancy, all the different models, cold starts, all that kind of stuff. I'll get that running here in a minute for you guys. But before
that was actually one of the
Mark,
other things about Moltbot is that its memory is all file based.
Yeah, no, it's not all file based. They were using SQLite. Well, I guess it's yeah. So they're using the same approach. It's SQL.js.
Okay.
So yeah, it's not that bad. Like they're getting now he's getting a lot of bad press. But aside from the fact that there was no inherent security sort of in the deployment pattern, which I guess is his fault, the actual structure of the code isn't bad. The system works, it's fast. It can be secured relatively easily by just literally asking Claude to make it secure. So he's getting some bad press for the most part. Let's look at this website you put together. What do you think?
Absolutely.
All right. Nice job on this website too. It looks awesome. It's the nice blend of like winter and console and you did a good job. Looks good. So
Yeah.
what should we tell everyone?
Okay. So we'll go up to the top because the date's the first thing. So 3 nights all inclusive. So everyone should know the dates here. So it's
March.
March 19th to the 22nd. So this is in Killington, Vermont, which is the best ski resort in the Northeast. And this is a beautiful time to go. Typically warms up, spring skiing, the whole mountain's open. So for those that like that, the way that we've designed this is the first day is an optional, so it's 3 nights. So Thursday night, and then leave on Sunday. So the first day on Friday is going to be a training day for those that can come with effectively just a desire and understanding that this is crazy, amazing technology that they want to learn. They don't even have to have it installed yet. Okay, so we're going to start out with just a fresh Claude installation. We'll use CodeSpace. And I've trained already a bunch of people on this, so I've got kind of like for the survivor's guide to terminal and VS Code for people that I've trained people in like that. So I've kind of thought about, do we use the web version? I think the web version, it lacks certain things. So that was actually my proposal. We can show it to them, but I've had no problem training people with zero skill. So that's the idea, is that you can come and learn how to use it and learn how to build some really cool things in that first day, basically just methodology and use. And then the other days are going to be much more of skiing in the morning and then hackathon. So it'll be like, what I thought is like, Ruve could show some of the things that he's doing. Other people can show. There's a lot of, so it's at the Red Clover Inn. So my wife and I own this place. This place is a 20-bedroom boutique hotel. We have a neighboring hotel for other people. We're going to cap this at 60 people because that's as much as we can handle inside of the Red Clover Inn. So we've got like a room that we can do the training in, and share a screen that we can get a lot of people in. And then as people are working, we've got several other rooms that have tables. And so that's the idea, is we're gonna have fun. We'll ski in the morning and work as late as people want to work in the hackathons. But it's about doing Agentics in Flow. Let me say that. Claude Flow. So we're going to have a lot of fun. We're going to, it's about community. So these prices here, so that they're all inclusive. So because we don't want anybody to have to go anywhere, worry about anything. We're bringing food in for breakfast, lunch, and dinner. And so that's all there. So we've got basically 2 tiers of accommodations, if you will, and you can either do double occupancy or single occupancy. And we have also an early registration bonus, and we also have lift tickets. So lift tickets, that's optional. That's on your own. If you guys want to go skiing, we have a Discord group. We will share information. So again, if you're a beginner skier, there's actually programs for beginners there, like half day. There's also, I'll probably lead if people want to do a more advanced things. I'll show you guys the mountain.
Yeah.
Well, question for you. How is the internet up there?
The internet is,
Because
we
if you're
have
splitting it between
basically,
60 people and we're all
Yeah.
technologists connecting to remote servers because we're responsibly deploying Claude.
so we have a gigabit. So yeah, we'll see. I mean, we might stress it out a bit, but we'll make sure that we've got some pretty good hubs in the space.
Yeah, we could probably optimize the back channel and get probably a bit of a boost out of that. We're good with networking, let's just say, but there's only so much pipe at some point. But I'm sure we'll be fine. And worst case scenario, we'll just use our laptops and create an ad hoc secondary network that we'll use ourselves. There's lots of hacking. Other thing I'm also noticed, hoping, fingers crossed, that maybe my first group of chips might be in by then, and I might bring a few along for this, and we can do some in-person sort of hacking of some devices and things, which could be fun.
Oh yeah, that'd be awesome. I think the other thing is like, for the more advanced people, we've been talking about, setting up your own. A lot of you guys have. We just ordered our first Mac Studios M4, so teaching people how to do that. So I mean, it's just going to be awesome. I think
Yeah,
getting
I
us
mean,
all together
I
at the same
can,
place.
the key to the Mac Studio, and Colby sort of turned me on to his setup. He's got a really good setup, and Tailscale, which makes it really accessible anywhere you go. And then basically I used Terminus across my Windows or Mac and kind of bounced them back and forth. But yeah, those it's really good for just messing around. The M4s are particularly powerful.
Are both
Um,
ends of your Tailscale network exposed over a public IP, or are they both double natted?
I don't know.
I ask because the
Don't.
Tailscale derp server is incredibly slow. So when I try to remotely access my secured clusters, which don't have public IP addresses, they have to go to a relay somewhere in the internet, which then
Hmm,
passes on the bits, which slows everything down.
good point. We could probably okay. Let's build our now. You got me wanting to just build Tailscale, right?
That's a funny idea. Hacking between schema. So yeah, so those of you who actually have your mobile phone set up, can actually be doing stuff on the chairlifts. That's funny.
Yeah, we totally could. Like, and
That's
I so
better.
I did attempt to learn how to snowboard a few years ago and realized that over the age of 40, I'm gonna stick with what I know. So I ski. I'm comfortable on the skis. My boys who are coming as well, they like to snowboard, and luckily I've convinced my daughter to ski with me. So there's that. Brenda doesn't really. She skis, but I don't think she'll ski. But that's okay. But yeah, it's fun.
I
Fun. It should be fun. Looking forward to a little road trip. So I think it's about 7.5 hours from Toronto, so not too bad.
I'll
And
probably
I
take
think we're
a Starlink
Yeah,
if we
actually, we should put up information about how to get there. I'm going to add that to the website. So the nearest international airport is Boston, and then there's a couple airports that are closer that are regional. Burlington's an hour and a half, and Albany is about an hour and a half. So that's a
like Albany, New York. I didn't
yep.
realize that was so close. Okay. Oh, we're going through Montreal, so a little family, little family trip for over the holidays, or there's a March break, I think it's something like that. Something going on in Canada. The kids tell me.
Yeah, that's
All
a
right.
nice route too to go up north that way.
Yeah. All right. There's a few things. Actually, before we do anything anybody want to cover, otherwise I'm going to jump in and show you. I'm going to show you how I build with ADRs because I'm building
Yeah.
building the next version of the Roov optimizer. So I showed you briefly the Roov optimizer earlier, and what it occurred to me now that I've kind of, I don't know what the right term is, but I'm going to say infiltrated the PC's internal workings. I now have the ability to do all kinds of interesting things from that perspective. So I can do all kinds of optimizations. And for anyone that's ever used Windows, there's this tool called PowerToys, and PowerToys allows you to do kind of automations and extend the core capabilities of the Windows system. So I thought, okay, now that I'm optimizing the memory and the CPU and GPU in the background, and the system's generally working pretty good, what else can I do? And so that's what we're going to jump into quickly here. And I'm gonna show you what those ADRs are, and where and how I build this. And we're going to spawn up a swarm, and we're just going to do it. All right. Um, so the ADRs are essentially my sort of approach to developing, and what the ADRs, just as a recap, they provide the mechanism to give guidance to what I build, so I can build really complicated things really quickly. And when you see sort of someone starting off in the sort of vibing world, they generally just kind of ask a few questions, they go back and forth, they iterate with the system, and then you might get something from that's interesting and decent. But generally what happens is there's a confusion of different structures, libraries, modules, and sort of architectural choices because there's no congruent plan to implement it, right? So when I build, I'm saying before I start, I spend an extensive amount of time planning what needs to be built and how it needs to be built using this kind of architecture, right? So if you're familiar with Spark, you'd be familiar with this idea of different, the specification, and all the various parts, the architecture, the pseudocode, and the completion, right? It's the loop, if you will. So this is basically doing that, but in a more structured way that allows it to sort of understand what it needs to do, but then question and understand the fundamental sort of principles of why different decisions were made, risks associated with it, and these risks often are relating to things like the security. So when you look at sort of the implementation, so far and how I've implemented it, you'll see. So I've got GPU layers, so I'm optimizing the system for my own requirements because I'm building the things that I want. So I built a system that optimizes specifically for my tool sets. So when I go in here and I choose to optimize my browsers or do a deep clean, this is essentially trying to optimize for the things I need it for. So now you see here in the top right hand corner, I just manually made about 10 gigs of RAM available. That keeps my system running, and so it's looking at the integrity of the system. And that's happening in the background mostly. I don't have to actually do anything. But being a fan of Power Toys, and if you guys haven't seen Power Toys has this idea that you can go in here and modify the various parts of your application. This is a popular sort of platform, tool for modifying your Windows environment. It's been around forever. And so you can do like different awake settings, commands, right? You can do automators and little add-ons and screen layouts, things like that. So it's cool for like the more rudimentary parts, and their advanced stuff. Oh, let's go back here. Their advanced stuff is interesting too, environmental variables. And so I'm like, okay, that's neat. What if I could do something like that? So since I'm already in the system, and again, there's basically what you're seeing is sort of my development. So the next thing I did, I create all these ADRs, right? So the ADRs basically starts at this control center. So the control center essentially defines that I want to create a system that allows me to sort of manage the various parts. So I've got CLI because I love CLIs, and you always have to have a CLI. And I've got a system tray component, which you see when I go here, and it tells me how much RAM and whatever I'm using and what the focus is. It usually goes to game focus because I have a tendency to use heavy amounts of compute and GPU, so it thinks it's a game. It's decided by itself what the optimal way to optimize my computer is because it's been running for the last few days. So then you see here the decisions that are being made. So like Win32, stuff like that, and architectures and so on. All right. So we've got the building blocks. So before I implement everything, I'm implementing a scaffolding to understand something. So now when I go in here, I've got a UI. So I built this UI isn't built with Electron or anything. So this is literally a 5 megabyte Rust runtime with an embedded Three.js and HTML. That's it. This is how I'm making it. It's responsive, all that kind of stuff. All right. So now if I go in here, I've got some options. You can see that I showed you earlier. I can go and I can do a deep clean. Now, when you do a deep clean, I've animated it and it does this little thing. I can do real-time views of it, all that kind of stuff. So it's kind of cool. Again, tiny, and I can change the settings. But now I'm in the midst of the sort of innermost workings of your operating system. I've created a self-learning, auto-optimizing system that can understand and view everything that's happening. Now, to Peter's point, is that kind of dangerous? 100%. It's possibly dangerous. So like anything, use with caution, and it works for me. I haven't published this yet because I'm going to build it. But the other parts, the main dashboard is published, at least for Windows. These parts I'm showing you are not. These are placeholders. So back to the sort of specification, I implemented sort of placeholders that will allow me to see the different parts. So this is a context-aware memory optimization profile that auto-detects your workloads development, gaming, creative, and applies tuned memory strategies. So it learns the structure of how your applications work. So I'm optimizing things like Photoshop better than Photoshop is optimizing itself, watching how the flow of information, including the flow to your disk, the flow to your network, the flow to your GPU, CPU, and other sort of variables in memory all play together, and optimizing that structure and rewriting the internal sort of structure of the operating system to be better for it. Then we've got health scores. I got, some kind of dashboard that allows me to see what the sort of structure of your computer looks like. I'm already doing this. So what I'm doing is just creating a way to see it better. But essentially what I'm doing is I'm essentially I'm optimizing the health of your system to work faster and more efficiently. And the results have been actually pretty crazy. I took an old Mac Mini I had from like 2013 or something, and I popped this thing on it, and I let it run it and do its thing because it's Rust. I can run it pretty much in anything that supports Rust, which is like, I just compile it for that particular flavor of the hardware, and it just kind of magically works. So then once it's in, it can sort of see where the problems are. And what I discovered, especially on the old Mac Minis from like 10 years ago, they put in substantial amount of headroom. So when you look at these computers, laptops, and so on, you remember that they build for an ever increasing OS size, right? So as the OS increases in sort of like amount of code and capacity, drivers, all that stuff, that it expands the headroom of the actual environment. So the first version of most versions of a piece of hardware includes more capacity so they can expand that operating system, which is the stupidest way to think about sort of development ever, because what you really should be doing is inversely saying every version of the software going forward should actually be more proficient, more optimized, more expedient in the things it needs to do. But instead, they're lazy. They're saying we're just going to push more crap into the operating system, and because our hardware has enough overhead, we can expand until we run out of overhead. Then we come out with a new version of the hardware, which is just it's just a dumb way to do it. This takes the inverse approach and says, how can I take this system and make it as streamlined and as optimized as I possibly can? So in this case, you see things like the startup optimizer. So this would look at the process of boot time. What's even more interesting, when I start looking at the sort of process of boot time, I realized I can actually rewrite the firmware that exists directly on the Mac Mini 2013, and it hasn't been touched in like 10 years. I can optimize that firmware specifically for the requirements of the things that I needed to do, namely AI-related tooling, self-learning, vectors, and that sort of thing. And so now I have this interplay between the initial boot, replacing that completely with a customized firmware that I wrote just for the hell of it. And that is contained within a WASM. Second problem I've run into is the Windows Linux subsystem, particularly on Windows, I guess is Windows Linux subsystem, uses way too much RAM for what it's doing. This will auto-optimize the sort of interplay between running a secondary Linux subsystem and your primary operating system, so the two don't compete with each other for RAM, which ultimately makes both slow in the current environment. It fixes that problem straight up. This feature right here by itself, that's a game changer for anyone that's running Linux and Windows at the same time. And this is just like a random thing I discovered while fooling around with RuVector in the bowels of the OS. Then we've got things like the build optimizer. So I do a lot of builds because I'm using Rust and sometimes C, that kind of thing. So I want the system to essentially be more efficient in that process. This will actually divert resources as needed and then send it to the particular build process going, and then it takes a sort of single. Most of the build systems other than Rust are sort of geared towards a kind of single tenant build, right? They're not fully utilizing the multiple cores in your operating system. They're basically just using one. This will automatically take those and spread it across multiple cores without you even asking, and take something that could, let's say, take hours. I can get it down to seconds. So it's quite amazing. And one example I was running a simulation for some of the chip stuff I'm doing, and the traditional C-based simulation and build process would take upwards of about 16 hours. I've got it from, let's say, somewhere between 14 and 16 hours down to 55 seconds. And that's just part of the build optimization. Leak detection, kind of an interesting idea here. This is a time series analysis of spectral decomposition, right? Well, I don't know. Memory leaks. Basically, most software leaks memory badly, especially those Electron style apps like the Claude Code desktop and any of the like a lot of browsers. They like Comet's particularly bad for that. What this does is it finds those leaks and then it creates a optimization to mitigate the leak itself, sort of independently of the application, learning and understanding and adjusting. This one's Markov chain-based application launch prediction. So what this does is every morning you log into your computer, you start an application, you go and check your email, your calendar, and run a few things. This learns the structure of how you operate at different times of the day, and then either makes suggestions or just straight up launches the apps and logs you in, kind of stuff. Again, security. Just because if you're automating a old application, like let's say you've got a point of sale system or some ancient Windows app was built 25 years ago, this sort of thing becomes very useful, right? Because it basically automates the parts that are untouchable currently because it was built in some shitty VB script system. Thermal. This one was really good too. So what this does is this monitors the thermal and the interplay between the temperature of your CPU and the amount of memory and the throttling of the CPU. So what it does is it proactively sort of prunes the activities and the CPU activities to minimize the amount of energy being consumed, to lower the temperature of the cores in your computer and get more battery life, and you're not going to get throttled when your computer gets too hot, because it basically monitors the sort of that interplay between sort of effort and heat. Craziness, right? Then I took the WASMs. So all the stuff I built has WASMs. So I'm like, all right, if I do a WASM, I can then have all my plugins that I want available for probably Linux, Windows, and Mac. I don't have to have different structures for it because I've compiled it to work across all the different environments. So you don't have to worry about like a Windows-based install versus a Mac or a Linux-based install. I can do one WASM to rule them all across all three platforms, and then I can load it and operate it, and there's no installation. It runs by itself. So basically, as soon as you get the WASM, you've got a half millisecond start time from getting the WASM to having it operate. No 5-minute install of a bunch of crap.
What
Then
sizes
you've
are you
got
getting on your WASMs?
depending on, but somewhere my smallest WASMs are 2 kilobytes. These are like algos that I put in like tiny little loops. Those would be like the temporal loops I talk about sometimes. But for example, RuVector is 850 kilobytes. So less than a megabyte for an entire RuVector system. Yeah.
Nice.
This entire thing I'm showing you currently,
I use optimized for desktop and not server, because I
I
imagine
don't make
servers
this.
on
I,
resources would benefit even more.
I don't make a distinction. It self-discovers that. But the biggest difference you're going to get probably is going to be in the AVX 512 vector instruction set that the servers and higher end systems would give you that I don't have here. But it'll figure that out. Speaking of bloatware, so now I can't get rid of all the bloatware, but I can actually suspend a lot of it. So if you're buying like Lenovo's and stuff or Dell's that have a lot of crap on it, it'll find and strip all that stuff out. And so then I got timeline, which is basically allows you to go back in time. I don't know about you, but I screw up my computer sometimes. This will do a complete time traveling system based on the optimal previous performance and then bring you back to that point at any given time. This is all using the RuVector hyperbolic structure graph and to basically keep track of how your computer operates over an extended period, and then figure out what the best optimal point was. And if hypothetically you run into problems in the future, you can roll back to that particular configuration. Now, the last part, and we're going to launch this swarm here in a minute, but in the last part, this part might be the most interesting. Everyone's on the Molt bot this week. Now, this in essence provides the ability, and I'm going to improve the UI. This is a rudimentary UI because it's the first iteration of the sort of placeholders. But what this does in essence is takes all the capabilities you'd expect in the Agentic Flow, Claude Flow, and all the agents you see me building, and allows you to operate the entire inner workings and application structure of your OS. That means you can automate everything. Like this is like Selenium on crack. This means that you can not only optimize like network flows, startup processes, the core stuff that makes the operating system tick. You can then have it do whatever you need to do in the application area of your OS as well. So, again, let's say you have an ERP that was built 20 years ago, you could have this system completely operated. But the interesting part, and this is where we're going to go back to the ADRs, is we are using a visual-based model to do it. So what's happening is I can essentially let the system run for a while, days or weeks, and all it's doing is watching someone use the computer. So let's say you have a point of sale system, and the computer does nothing other than enter people's reservations, puts them at tables, and figures out where and how to seat them or whatever. People do that generally. In this scenario, I'm feeding the output to a local model, one of these several local models that essentially allows me to use a kind of computer use directly and then learn incrementally as people use the system. And eventually, after not that long, to be honest, maybe an hour or two, the system then knows how to use that application and then can completely and autonomously operate against it. It's similar to how I set up the Claude Flow browser system that can basically go to websites and then discover how to use those websites over a kind of trial and error period. But the difference is, rather than going and doing this kind of, here, go look at the website, figure it out, and tell me what works and what doesn't, it's essentially watching you or somebody use a computer and then learns how to operate it. Taking it a step further, I haven't tried this yet, but there's nothing saying I can't get this to go play video games. It can do everything, and it can learn. So I think the next thing I'm going to do after we get this swarm going is I'm going to get it and point it at some like Twitch channels and get it to play some video games and see what it can do in the video game front. All right, so you can see here.
What you want to
Yeah.
add? Do you have a port monitor covering it, and then what you want to add virus scan into it also?
Yeah, it's built right. It's built in.
Okay.
I cover you guys. It uses AI defense.
Oh
It-
yeah, cool.
So
One of
yeah,
the-
so the AI defense systems, desktop agents executing real systems, create critical attack surface, prompt injections, etc., etc. This is the same security system I use for Claude Flow, the same for Agentic Flow, the same one I use for the Ruve bot, Ruve Vector. The reason why I guess people aren't yelling at me because I've thought that the system is going to be exploited and have real-time mitigation of those exploits.
On the
That's-
WSL2 thing, you have the memory, which is awesome, but the real problem is actually disk, because it never trims the disk. So
Well,
even if you delete files, is it possible to build an ADR that handles that?
yeah. So that's a really good point. So in that scenario, what we could do is probably a bridge between WSL and the sort of parent here in Windows, and then have some kind of disk optimizer, like a defragger of the old days.
Yeah, it
Yeah.
leaves any space you've ever used in the file in Windows, and it never goes away, and it will just fill a disk.
Exactly, and that's a great idea. That's a great idea. All right,
When
so
you
what
were
we're gonna
building
do,
out the ADRs, is it meant to be linear or is it just how the numbering system worked out?
it is meant to be linear. But I don't have to implement it linearly, but it is linear purposefully. Now it's linear because some things need the requirements of other things. So when we go back into the last ADR, you'll see here that there's references to other ADRs, right? And that's where the linear sort of ADR. Yeah, see here. So
And
root
that's
vector
like
existing
old
in.
programming languages, go to line.
Yeah, and that's what keeps it on. So remember, there's anti-drift mechanisms in my swarm now that keeps the thing sort of focused and not drifting off where it shouldn't. And it also reminds it that there's stuff that it can borrow and reuse rather than going and building it again. And ultimately, I don't want it to build things that already exist. So when I see my collection of ADRs here, it's see this is from ADR 22. So I'm on ADR 25. So ADR 22, just to refer to that for a moment, is GPU memory optimizer. So it's saying somewhere or other you probably want to use that. And then this particular one, we can check what other ADRs are referenced ADR. And so in this case, we see that ADR 18 has a reference to the VRAM. So I've got a VRAM optimizer. Now, remember that I'm incrementally implementing this through a series of steps, right? So for example, at step, what do we got here? Macro ports. Let's look at some other ones. There's a lot here. So here's the one from my LLM inference. You can see that's number 8. LLM inference using root vector is a particularly integral part of what I'm doing. It provides the ability to learn. It provides the ability to remember and a bunch of other things GPU related. I've essentially kind of built my own version of Llama CPP, and I want to use that instead of Llama CPP.
Do you create ADRs as a side effect of your implementation, or you start with ADR?
I start with ADRs. So you see the first ADR is basically the most critical. It's the thing that works right now when I'm showing you, like it's this, right? I go in here and I can do this sort of stuff. So this was important. So and that works. So everything else kind of bridges. So that's the root vector core. I'm essentially creating WASMs in the internal workings of the system that I can, and then when I go and use Mac, like or when I showed you the Mac version, here's my Mac, and it's obviously in a different spot on a Mac, but the capabilities are the same.
And as you're
Right.
developing, you may be reordering these ADRs.
Yeah. Well, no, I'm not reordering them. I might be adding new capabilities or updating what's been completed to them. So now that we get that, what we're going to do is we're going to spawn a swarm, and we're going to actually implement this whole darn thing. So in this case, and this was running on my.
What makes Claude Code or Claude Flow use the ADRs? Where's the link between?
It knows in README. Oh, not README, Claude. Sorry, where am I at here? Oh, Claude MD. Oops. Why is my mouse too sensitive? There we go. So this is my Claude MD.
Right.
But one of the things you're going to see here in my Claude MD is the ADR. So it knows it knows sort of ADR structures. Where's my other one? ADR routing. So and then in the Claude in my commands and skills, I've got ADRs as well. So I've kind of infused it as the core sort of tenet of the system. So it kind of just knows to use ADRs for me. I built Claude Flow for me. It's the way I build, but it definitely.
Are there circumstances where people shouldn't use ADRs now?
I used an ADR the other day to do a PowerPoint in my Note LLM I did the other day. I created a series of ADRs for each of the slides, and I got spectacular results from using it there as well. If you're looking at complex guidance, there is nothing better. Like
I'm wondering why it's not default. Like I thought when I upgraded to V3, I'd pull in the defaults, because I don't.
Yeah. I don't know why it's going so big, but basically this is an ADR for building out my different slides and whatever. So I did I think 12 different ADRs, and then I did an overview of each slide 01, status accepted, context, design. It's got everything. But the result was spectacular. Actually, this isn't my favorite.
But isn't in this case ADR is a part of your S in Spark?
It is. Yeah, it's exactly what it is.
So it is a spec, right? In a sense.
Yeah, but
Mark, you
but now the output of this thing is just astounding. Like I got perfect structure. I got exactly what I wanted to say. It created my charts and my execution. You know, it's and then I'm like, I don't know if I like that one. I'll do some more. What does this one look like? Right? Oh, this one's a little too purple or whatever. Okay, I don't like that. So but it gives you just spectacular guidance, right? And the results are astounding. Like look at the like
I'm
you know.
completely sold that it should be default, and now I wonder why it's not.
oh
Okay,
the
because we just invented it.
Perfect. Let's put it in.
All right, so
ADRs
now we
are
got
good
it.
for like
So
multi-turn loops. I don't know if you'd need
uh,
them for maybe anything less than 2 or 3.
anything of any decent sort of guidance. All right, so let's go back to my GitHub here, and you'll see here in my GitHub, I've got all the ADRs. If you guys want to see it, I think it's in a branch. You have to go to that branch. But then what I did is I created a bunch of issues. All right, so you see that I got all my ADRs here that I'm going to do today. Starting with ADR 12 because I haven't implemented that. I just implemented that, but we're going to go with ADR 13 through 25. And we're gonna crank up a swarm on that. So this is what we're gonna do. So we're gonna review and actually I'm just gonna go here and I'm gonna drag it in just because I'm lazy. So I'm gonna go and I'm gonna put in review. Review ADRs 13 through 25. Spawn. I'm gonna use a hierarchical mesh. I gotta spell it right. Mesh swarm. And actually, you know what I'm gonna do first? Create new branch. We'll call it Vibecast 2026. Well, I guess it's 29. Let's go with 29. Vibecast 29. And I'll do a 129. And hire a swarm. I'll say implement, fully, test, verify, optimize, and document. Watch for regressions in currently functioning and capabilities. Update dashboard. Update UI index HTML last. Use modular components and WASM where possible. Which I've already said, I'm just reminding it, because it's going to spawn the thing. Yeah, this is it, right? And then start mission. Actually, you know what I'm going to do? I'm going to say update the related GitHub issues using CLI frequently as replies to the various issues. Do deep security review and fix any issues and with a final security report as a GitHub issue ADR DDD. Start mission, something like that. All right, so what's going to happen next? And by the way, this is actually running locally on my PC because I'm running because I need to be able to use it. So as it I'm gonna be able to see it and change it and interact with it possibly. Now this is compiled, so it would have to compile before. And I'm doing a lot at once, so I'm sure there'll be bugs.
Hey, Rube, a couple questions about ADRs to issues. Is it really one-to-one? And do you rewrite it at all, or you just say put this ADR into an issue?
They're not one to one. The ADRs, they're more verbose in the MDs that sit on the hard drive, which provides a sort of grounded truth for it to follow locally. If you go back to well, that's the actual UI. Let's go to one of them. Let's go to the Agentic Desktop Automation, which is really kind of probably the thing that's going to be the most useful of all the things I'm building. But so you can see it's more rudimentary. But for what it needs to do, it's in a way that I can understand it better. I don't need the verbosity that you see in the one here, right? It's just a lot more stuff, and I just need to know that it's done and built, right? This is how it's made, so it's a lot of detail, right? It just goes and goes and goes on the detail. It's great, but I don't need that here. So what
So
I
you
need to know
build the
is
ADR first, and then you build the issue to reference the ADR?
I build the issue, yes, after I built the ADR, correct. So I built the ADR and I did several revs on those ADRs. Like I'm like, oh, it doesn't have this or that. Now I want to use this particular WASM, or I want to use this feature from Roof Vector or whatever. And I want to add, so I spent quite a bit of time fooling around with the sort of back and forth of those ADRs before I was happy with it. And that's how I ultimately came up with 25. I didn't do all 25 at once. I basically kind of went through and did I want a memory for doing generative audio from RAM patterns. Like, I don't know, I wanted to hear the brainwaves of the system. I thought that'd be cool,
Yeah.
that kind of thing. So this allows me to generate audio from it, or this one's a data export. So I want to be able to take my training. So if I'm training the system on my PC, I want to be able to allow other people to use the sort of optimized version of my PC or Mac, right? Because why bother having to learn when you've already learned? It's kind of like the Matrix. I can download the skill in this scenario. So I can, and this one allows me to export it. Then eventually, everyone was bugging me, and I'm like, "Why? Where's the Mac version, man?" So then I'm like, "All right, I'll do the Mac version." And this was on the 28th, yesterday, I guess. And so I built a Mac version. This is what the ADR looks like. So, because I built it in Rust, I don't have to specifically worry about the sort of details of the migration, because all I need to do is work on the hooks into the Mac OS. So it just kind of worked in like minutes. It was super easy. You can see that I've got a few different things. I should probably do like a homebrew install. I think I do have one. I just haven't tested it, but stuff like that. So it's not the most complicated. Then I'm like, oh, let's create a UI for it, like Power Toys, right? And that's where I got totally carried away, right? So here's the mock-up of what what the user interface needs to look like, the structure. And then I went and built all the other things. You can see, and there's a lot of detail here. Like thermal aware process scheduler, that's someone's startup, I think. And that's just a random feature. Here's what the widget looks like, or will look like once it's implemented. See here, we got consequences, positive, prevents thermal throttling before it impacts foreground performance. Silent mode enables comfortable use in quiet environments. I don't know about you, but I hate when my fan goes off when I'm on a Zoom call. It drives me nuts. This solves that problem. And I'm already using that, by the way, in the current implementation. So it basically balances it so it's not, your CPU isn't getting too hot, but it's also optimizing the flow so it doesn't get hot. And then you see here it has security considerations. Again, everything always has security considerations, risks, and then
It
there's
looks like the
implementation.
ADRs are specialized. Do you ever ask what's missing, and does it ever recommend? Are
Yes.
you seeing this? Okay.
Yeah. What's missing is my go-to. Every time I think I'm done, I say, what's missing? Or what's left to do? Is it secure? Prove it. Is this real? This looks like BS. Prove it. How do I know this is real? Oh, well, you have to, if you install the shitty version of this library that does sort of kind of similar things, then we can compare it. All right, let's do that. Well, it took 16 hours for it to run in that crappy environment. Yours took 55 seconds. Okay, now I'm starting to believe it, and at which point I'm like, okay, so let's do something else that allows me to believe it. you know, I'm basically critical of the system until I'm proven otherwise. Because a lot of the stuff that I'm doing here flirts on this space of like not possible or never been done, right? So the AI is like, nah, that's not going to work. Well, it just worked, and you just showed me it working, kind of thing. So yeah, I'm proving it to me.
Are you using PRDs anymore, or are they in this?
This is a PRD. I'm 100% PRD.
Okay,
This is
ADR is a PRD. Well, what is
well,
PRD to ADR?
well, it's just it's just a different acronym of a synonym of the same thing. So a PRD is it? Well, here let's go to our friendly
I feel like
Gemini.
a product review, product requirements document precedes the build, and architectural
Yeah,
design review is a
Correct.
pivot during the build.
yeah, that's a good way to look at it.
It's
They're
actually
different parts.
ADR is architecture decision record.
Yeah.
Oh, thank you.
Okay,
So
so they're
it's
different
supposed
parts of it,
to.
but they're all part of the same thing. But they're different parts of the same things. One's functional, one's technical, one's implementation. So the product requirements
Business.
is where, yeah, the requirements is what I start with, and it's like, why am I doing it? Why do I need to do it? Kind of stuff. You know, the audience. It's so the PRD is nothing unless it can be implemented. So then you need some way to define why, right? ADR is short form, you know, it's that captures the specific architectural choices made by the engineering team, travelogue of sorts. Then you've got a domain-driven design, and this is the how. This is the part that allows me to understand that I've actually done it and how it actually works. And I guess it aims to ensure that the code structure matches the business logic by using ubiquitous language that both developers and business experts understand. And what I like about the DDD is I understand it, right? Where sometimes in the ADRs, it's so freaking technical that I'm reading it. I'm like, what the hell does that even mean? And I know it works, but I need it translated in a way that I can actually understand it, which ADRs don't always do the best job of. They're great for keeping the thing grounded and avoiding drift, but they're not great for telling me exactly what that means. The DDD does that.
I have a different DDD that I use. It's document driven design or document driven development, and you write it in a retcon format, so as if it's already built and you're just describing what's built. And so then the AI is building off of that description. And so it's another, methodology for build.
Yeah.
I think what we've all learned is there's more than one way to vibe code these applications. So the best part, because coding is so cheap, try them all.
Yeah, I think
pick the best.
I think the key here in what I'm doing is I'm saying to almost exactly what Jed just said. You can invent your own structures that you can qualify and quantify pretty easily, and then you've got the tooling around what I built to help it steer it, like let it learn, and then have ways to measure whether it's drifting away from what it originally was intending to do. Now, whether is the ADR, the DDD, or some other scheme that we can concoct better, probably for different things. There's probably different schemes that we can come up with that would solve those problems better. But for the types of things that I'm doing, the bleeding edge of the bleeding edge, this is the best that I've been able to come up with. It builds, you guys see it's building anything, whatever I can dream up, it literally will build it. And this is how I do it.
So if you don't want to make ADR and DDD default, maybe get Claudeflow to encourage us to turn on those features, because
they're on by default. Yeah, they're on by default. Now,
but I don't see them. I'm using V3 and I don't see those artifacts in my.
Well, that's because you're not asking the right questions.
But that's what I'm saying. I don't necessarily know to ask.
I'm not forcefully telling you your architecture. If you were to vibe it and and so on, I could probably make it more forceful in the implementation. But the problem with that is then I would be struggling if I wanted to ever take a different architectural approach. So there's a balance between sort of forcefully giving you my approach. Now you can invoke it, just say I want to use ADRs, and suddenly the system will work better.
Yeah, I recognize that from the chat. But what I'm saying is that people who don't participate in these calls would not recognize that. So if the system encourages to use certain features, then I think more people would be on the frontier.
Forcing
Yeah,
features
maybe.
on people has not always been well received.
not
Consider,
I don't
for
like that.
example,
Just
U2's
suggesting.
iPod Red.
I built this as an agentic engineer's toolkit.
Mhm.
I don't what it's not for vibe coders that don't know that they don't know what they don't know.
Sure.
If you don't know that you need a PRD or ADRs or DDD or some mechanism to avoid drift or you need to secure your system, then that's a whole other problem, right? I'm
Well,
building
if
this
you were
for people
listening
who
6 months ago, you were very smart, and then you came back now, you wouldn't necessarily have been along the journey. What I'm suggesting is that we help people along the journey.
Yeah, that's probably training materials, maybe social media, that you maybe asking the system how to build something securely would probably be enough to make that happen.
This is jumping in
Uh,
the deep end.
yeah, I'm showing you guys like I'm showing the most complicated thing I can possibly build today.
Yeah,
Right,
right.
right. A few days ago, a few weeks ago, we did the bird thing, right? So this is not beginner's agentic engineering. I don't think it's the opposite.
Mhm.
But yeah, but this is just I think what you're describing is like how do we educate people to understand that they even need to use an ADR or PRD or what have you, and the differences between them. And now what I could hypothetically do is create a wizard possibly that maybe like
I think we
kickstarts a
I
project.
think we just described the workflow. My challenge with this is like if I go into the repos, I see docs ADRs, but I don't see where I should put PRDs. And generally there's no PRDs. And you talk about you like
Oh,
reading
the
DDD because it's a review document. Well, it doesn't generate a
oh,
DDD unless you ask it to. So
oops, what's going on, guys? What I can show you guys? Why is it zoomed in so much? Come on, zoom out. Smart camera, not so smart today. All right.
Because you did the L
wh-
sign.
yeah, what I could show you guys is where I do my PRDs. Yeah, and that's on my gist. So
Martin, for your specific case, it sounds like a skill might be more better, or might be an improvement so that you can provide an opinionated path through Claude Flow 3.
Yeah. Whatever works.
yeah, so here's an example of a coherence engine. So this would be my PRD. So this is basically deep research. This looks at different coherence systems. A lot of what I'm doing right now is about how systems are structurally keeping together. The kind of dark matter, the antimatter, the anti approach, right? That I've been liking lately. This is
so how
looking
does the
at sort
repo
of
reference this
I,
PRD?
I post this file in the initial repo when I start it, or in this subfolder when I start it, and then it all kind of branches from there. So in this, I share them here so people can find them. But in this case, I literally just pointed at this particular URL or copy it. So if I'm using Claude Code Web, where it's not easy to upload a file, I just pointed at this thing and then it knows where to start. This is looking at sort of the different, frontiers and sort of why and what I want to do. And then I'm starting to do some architectural decisions that I've actually done as well here, just to show what the sort of result of that PRD would look like. And when I'm doing the more kind of crazy stuff, like I don't post all of it because I don't want to look like a maniac. But here, like let me show you something a little crazier. And so if you go to my, I think it's examples, example, I did a delta based structure. Yeah, delta behavior. Now, delta behavior, I don't know if you guys are familiar with this idea of delta. There's a whole subsection of the internet devoted to this idea that delta behavior is the sort of underlying premise for consciousness, and it's a whole weird thing. And so people who sort of apply this philosophy, they do it theoretically, right? So they think that this mathematical equation is like the equation it's like the God equation or something crazy like that. So I can't help myself. Like I enjoy a crazy sort of rabbit hole as much as the next guy. So this particular approach allows me to explore this idea that delta behaviors, when local chains, states update and are bounded steps. I'm like, well, that sounds a lot like what I'm already doing, global preservation and violation and other various things. So then I'm like, okay, what the heck am I going to do with it? So these are my exotic. I always, when I'm digging into the world of crazy and these sort of weird sort of Reddits and things where people have these crazy ideas. And if you guys are into the Delta thing, I'm not calling you crazy. I'm just, it's out there. So I'm like, okay, I can do self-limiting computational events, artificial homeostasis. That's really cool. All these things, when you think about, what they're doing, actually fit really well into my root vector structure because I've kind of done a lot of the sort of underlying work already to do it. So I just need to figure out how to do it. And then this one actually kind of caught my eye as well, this idea of pre-AGI containment, bounded intelligence with growth. Like, okay, interesting stuff. So then we look at the 3-layer enforcement. This is sort of explaining to me the structure of how it needs to work. Again, this is a really, really, really complicated PRD, right? This is meant to be the bridge between theoretical sort of research and attempting to be the guy that builds it first kind of stuff. So it's looking at performance and WASMs. Now, if you go into the ADR folder, you'll see that I've created, this isn't nearly as complicated an application as what I was showing before. So now we've got the initial ADR. So I took the PRD, which is much longer than I was showing you. And now I'm like, how do I build this thing? So I've got this sort of delta behavior, moves only allowing allowed trajections, bias towards closure over diversion. So it's actually a really interesting concept when applied to agents and hive minds, right? Because it's bounded. It says I need a conscious construct that's capable of evolving, but not evolving to a point where it doesn't become useful, right? Evolution in this scenario is only useful if it solves my problem and continues to solve my problem. If it evolves beyond what it needed to do and does something completely different, then it's completely useless to me. So this is what this system is trying to do. Now, I have no idea what this 72 thing that keeps coming up. I think that's some kind of like weird part of that whole subsector. But anyway, that's why this feels like 72 is apparently meaningful. What is not delta behavior? And then we go into sort of coherence related activities. Now, actually, before I go to the next one, the most interesting part of this actually is at the end. So when we see decision learning and structure, this is telling you about how it's going to learn. But you also see here sort of the consequences of what it's doing. And I actually really enjoy this idea of positive, negative, and neutral consequences. Systems are inherently stable, failures are graceful, behavior is predictable within bounds. So that part of the ADR is actually quite useful to me. And the other thing I always try to do is I want to include the references because everything I'm doing, I'm basically borrowing from others. So most of these people were never actually able to realize the things that they had theorized, right? And I'm showing up and basically on a hour call on a Thursday saying I can implement their theoretical thing in a functional way, which is a kind of bold and boastful statement. So I want to give credit there, so I include that frequently. Yeah, this is what it looks like. And ultimately, yeah, sure.
But when you build, how mission ready do you want to be when you start versus building a plane while it's in the air versus refactoring? Where's your balance between those three?
There's always a bit of refactoring. It's just it's like when you get to the end of something, you're like, I don't know if I like the color or the location or the specifics, and there's always a little bit of that human that requires to give it a little finesse, and that finesse, and for me, the finesse is the best part. I really enjoy discovering, so the iteration at the beginning, like, oh, I discovered some crazy new research that I can now implement, and when you look at my pulse in ChatGPT, you're going to see this in action, right? This is the best thing about ChatGPT by far is pulse. Like, look at mine here. Every morning I get up and I get on my exercise bike and I seize this new thing, like, here, track new implement algorithms, or here's the state of the art daily briefing on the things that no one's ever implemented before. Like literally a brief on architectures and approaches. Some days there's nothing, but some days I find like MinCut. And then I've got temporal gating for living world models, tested on-tile MinCut microkernels, living neural trading memory design. Like this stuff is actually the stuff I want to know. It's amazing. Here, look at this one. This is an 8-bit or 8 kilobyte Rust WASM deployment recipe. Like, if you know anything about me and my chips, this is exactly what I needed today. So yeah, this is where I do a lot of my discovery. Global, this tells me about global DRAM, in the Intel 1.8 node manufacturing strategy. I know you can tell by my chat GPT that I'm a super nerd, but it's definitely interesting to me. And so now take this and I'll say, create me a PRD. Right. So this is basically a PRD already, to be honest. I could just copy and paste this. Looks like it's essentially a PRD because I asked it to give me the outputs in PRD style, right? So I'm basically copying and pasting this into Claude Flow and saying, go build that. Here.
Do you ever go back and look at all of your logs, all of your Claude Code logs, or have it analyze it itself?
Yeah, I do. I've got a integration. So with I use the MCP tool. So we go in here and we go personalization, and we go to, where is it? Apps. Yeah, I've got Flow Nexus is my integration. So the Flow Nexus system allows me to connect to all my intelligence systems everywhere and anywhere, and so it knows everything there is to know about me in real time because everything is connected to everything I'm doing. All my Claude flows, all my different computers, all my code spaces, all my servers are sort of aggregating, but they're not aggregating everything that's important. They're using RuVector to compress and get the parts that accelerate the other parts that I'm doing better. So when I go in here and I do a new chat, and this is hilarious too. You never know what you're gonna get, but pulse check. This is like, what's going on with me?
It's like a
So
second brain. It's all-
yeah, so momentum is real. Cognitive V1 is at fab, collapses external risk. CSE win plus Arista shifts narrative. Okay, you guys are getting a little too much into my personal life here, but you get the idea. It knows about me. Coherence is but what's working? Coherence is a first-class signal. Min-cut gating, event-driven loops, deterministic explainability. These form a defensible spine across silicon, firmware, and software. The story is now simple enough to repeat and hard enough to copy. I literally just said pulse check. And so now it's saying lock one flagship demo end to end. We're one, so this is my guide to success in essence. So 3 years ago, when I first got access to ChatGPT, I'm like, what can I do to sort of reinvent myself for the age of AI? And it set forth this path. And all I'm really doing is following sort of its guidance to get me to where I want to be, both in terms of my personal and professional sort of points of view.
Is Pulse in beta? Because I can't access it on my end. I get a 404.
I don't know. I just slash pulse. Is anybody else have? I just assumed everyone had it. I don't know. I've been using it for months.
It's only available for the $200 subscription.
It's worth every penny. It's worth every penny. I didn't realize it was only for $200 subscriptions. Yeah, it's spectacular. Look, check this out. No, so I get up in the morning and it sends me a freaking note, like in that little sort of notifications you get from and it says, "Hey, Rube, there's a new algorithm you should check out." Oh, look at this one. It's decided to give me a 200-word opinion in my voice. It doesn't. That's not my voice, but regardless, it's funny. 35 implementable ideas with links, incremental GNN, GeoVector. So then I'm like, okay, what's the one thing that is a game changer for me? I don't know. Right? It's already one thing that changes everything for you. You stop trying to answer. Oh, this is very existential in its response. But see it knows about like, okay, what should we build next? I'm sure it's gonna be crazy. Build the coherence control plane. I already built that. Think 100 years in the future in the future using using available technology today. I love doing that. That's like my go-to, like some arbitrary date in the future. That's what the next thing is not open system, it's a substrate shift, building a self-binding reality. All right. He wants me to try to be some sort of weird Greek god or something. What this means in plain terms, a system that does not just model the world, but becomes part of the world's resistance. Okay. Interesting. Guys, I gotta check my calendar quickly and make sure I don't have anything at the bottom of the hour. Actually, while we do, I'm just going to see what's going on with this swarm. Swarm's completing. Now we can go back. Just one sec, so I get sidetracked. All right, sorry, folks. No, we're good. All right, I'm gonna go back to GitHub for a sec. Right here, GitHub, Vivecast. Here we are. So now I can go back to my issues. It hasn't updated the issues yet, so it's not quite done yet, but it's almost done. A bunch of them are complete. Yeah, I can check on the code. Yeah, it's still implementing. This is a pretty extensive swarm that I'm doing. It might take longer than we have. Who knows? All right. Any thoughts? I'm being kind of rambling here for a bit. Matt, what are you thinking?
All good stuff. All good stuff. And then it's time for another shedding of a skin and leveling up. So, moved into the tools yesterday, and it's a new next level. So, all good stuff.
Yeah. Well, actually, speaking of like Nick, how's it going? I saw you've been posting a ton of stuff, and I love your new avatar. We've been enjoying it all week. We call him Super Nick.
Yeah. If I had a $10,000 suit and a $10,000 photo shoot, but yeah, I've just been building a lot of stuff. This ADR stuff has really been helpful, to keep these systems like knowing what specifically you want and not having issues executing it. No more duplication of implementations and things like that. Like it just wipes all of that nonsense out. So I've enjoyed that. Yeah, I just basically build a couple projects, and I was like, Reuven, look, I built something, it's cool, and that was maybe like in late August or something, and I'm like, so what do I do now, And then Reuven's like, well, just put it into ChatGPT and ask it what you should build that can use it, or is it related to it, and I just kept doing that, and yeah, just kind of following the rabbit hole where it leads.
And by the way, we are going to be doing an election for some new board members of the Agentic Foundation. We're extending this to 7. Nick, you should totally put your name in the ring for that, by the way. That's going to be announced probably in a few weeks. I'm probably jumping the gun. I don't know if Rob's still on the call or not. But
that's okay. You're not jumping by much, though. I mean, I think the announcement from the chair, from David and you, is planned for Tuesday, and it's fantastic. So it's quite the evolution.
Yeah, and there's a few folks I like to call out, like Antoinetta. We'd love to have you put your name in if you're open to it. We're trying to extend this and make it more sort of equitable. So yeah,
I'll take a look. I wasn't aware you guys are doing this now.
Yeah, well, I kind of just leaked it just now.
But thanks for the invite. That's awesome.
Yeah.
Oh, Nick, that's an awesome suit.
Super Nick.
So just so everybody knows the details, about the structure, the mechanism, the timing. All of that will be coming out on Tuesday. The aim is to have nominations over the next 2 to 3 weeks. The election in early March, and the new board for the next year starting in the beginning of April.
Yeah. No, it should
And
be
just on
good.
the feedback front, just to point out again that there is this CB radio section on Agentic.org/community. You can tell us what you think. Like if you just got general feedback, you want to propose an idea, if you want to be a guest on the Hackerspace, all these things will help set our priorities.
Yeah, and I'm going to share. I'm going to share the URL as well for this vibe retreat for you guys, and I think I forgot to do that from Mark and company. Nick, or sorry, Martin, if you want to share the link to the CB radio, feel free.
Yeah, I'll do that again. 1 sec.
Yeah, and most of you should be receiving an email about the retreat as well.
Yeah,
like now.
I think Guy, you just mentioned, who can join the board. It's a meritocracy. So basically, if I think there's a requirement for you to be like a good standing of the Agentics Foundation, which probably means you got to sign up for the one of these subscriptions or whatever we have there. So and I think that requires three months, I think is what we were describing. But other than that, we're doing that mostly so that people don't game the system, But other than that, we're gonna have a voting structure. I'll probably might use my consensus mechanism and encryption from QDAG as the voting mechanism. But you'll get a vote, and you can vote for the folks who are putting their name in the ring to be on the board. I think we're gonna stagger it so we don't have like a kind of election cycle. So rather than having a everybody all at once, we may do it over the span of a few months. Otherwise, it starts to look like an election, and we don't want that sort of feel to it either. Anything? What am I missing, Rob?
So we're going to appoint a chair to manage the election process. And then, yes, folks can run the mechanism between a 2-year and 1 year so that there's staggered experience as the board is in rotation. But yeah, so the chair of the election will manage everything, make sure that everything is well understood, well known. And the qualifications around it's a working board. So the idea is that the board members are contributing a certain amount of hours per month, are active in at least one committee. And we want to make sure that board is really engaged and carrying some of the weight of the workload. There will be a managing director that the chairs and committees report to, and that works with the board, and that just gives us so much more bench strength going into 2026, and really unlocks the energy, centrally and from chapters around the world. So, yep, that's the general idea. And again, that entire architecture of that process, that'll be released for everybody approximately Tuesday afternoon.
And do you have to tell them how to talk like a pirate, though, right?
Yes, when it's all in favor. Aye.
So
for 2 hours in the middle of the night last night. Yeah.
Yeah, we're just so you're aware, we're like the opposite of I would say the Linux Foundation. We're a ragtag team of pirates, and when we do our board meetings, we have a tendency to when we have consensus, just to say aye or ar like a pirate might, because we're weird nerds, I guess. But we're the we enjoy being the kind of whatever the opposite of those guys are.
Yeah.
So just a heads up, you got to learn how to talk like a pirate.
Personable. Yeah, it should be it's going to be nice. So that's an expansion of the voting class, and it's an opening and an expansion of the board, and with a little more defined rigor in terms of what that represents with committees and committee chairs, because there's an awful lot of things that can be done. And now put that in tandem with the incredible news out of the marketing committee from Leandro, right, with the Google support.
Yeah, we're not sure of the exact final amount, but it looks like it could be, I'm going to put a question mark on top, but it could be as much as 10,000 US a month devoted to Google Ads for their open or their nonprofit. So what we're thinking is we're going to allocate that some to the kind of corporate, well, it's not corporate, but the main Agentix Foundation. But the rest we want to make available to spread the word on local chapters. So you can, and I think we're going to get more bang for our buck if you have, you know, some money to buy, you know, local ads to promote your meetups and activities and so on. And I think, you know, buying some ads in Helsinki is probably cheaper than trying to blanket, you know, the Silicon Valley or something.
Lovely. Yeah, really excited. I mean, that could be a significant budget for the chapters. So that's a really neat aspect.
Yeah, 10,000. Yeah, Nick, you're more familiar with this sort of thing than I am, but 10,000 a month is not bad, right?
Yeah, USD. I'm assuming. So you know, that's we can do a lot of damage with that.
Yeah.
Incidentally, that would be per entity, because if they are incorporated as their own entities, then that applies.
No, we've got an Agentic. So we've got an Agentic management tool, which we actually, where the heck did I put that? Anyway, we've been Leandro and the marketing crew and I've been putting together a system that'll help manage that. So we would have to facilitate those ads. They're not getting the access to manage those. We would, our agents basically would, but we will have a system that allows them to make use of it, and we'll be able to do, you know, country or specific or city specific targeting, probably city specific targeting, I would guess.
It is an interesting point that you mentioned, though, Martin, that as more chapters graduate from the light license ambassador into a full not-for-profit registered chapter, that might be robust enough for their own application.
That's right.
And their own budget. Yeah.
And that could be controlled through the tools, right? Because from a distribution standpoint, we want to federate.
Want to be in sync. Yep.
Yeah.
Yeah. Fascinating.
Yeah. Makes a lot of sense. Now there's a lot we can do. I think that, you know, and we can definitely be everywhere we need to be as well. You know, if there's branding conflicts, if you know what I mean. So yeah, it'll be useful for us to get that going. And of course, we're gonna make the marketing tools that we devise to manage the whole process freely available to everyone. To use if they want to use it for other purposes. Why not? Yeah. All right. So, yeah, the swarm. Oh, yeah.
Yeah, for the retreat, there was a request in the chat around potentially doing it hybrid also, but we may have resource constraints, bandwidth constraints. So I'm just putting that out there. I saw it in the chat. So
yeah, I 1 gigabit in 60 people sounds like you know, not exactly a lot of bandwidth for video. And
Starlink is at a point. I would imagine quite a few members that may be attending would have a Starlink. They're portable. I'm supposing they would. The system will be responsive enough over.
That's actually not a bad plan. How much does Starlinks go for anyway? They're not that expensive.
Well, you can borrow mine, but that was only one.
I have a travel one as well, and it's only an extra, I think, $11 a month on top of the regular Starlink.
Okay.
They keep sending me offers to reactivate mine. I had it at the cottage, but then we got another system that was cheaper and faster.
Yeah.
It's not faster, but it's cheaper.
You launch your own satellite.
$200. They're not bad.
Okay, let's do that. Okay. Maybe I'll pick one up then. Maybe I can try hacking it. Maybe we can create
Rubek
some
chart.
kind of like cluster of them, and like you do something that allows everyone to benefit through that, like a mesh.
It will be a story in itself.
Yeah. A new piece of hardware to play with, sure.
Yeah,
You sold me.
Rue, figure out how to juice up the Starlink so it's like crazy powerful or something, you know?
Yeah, it's well, as long as it doesn't break the terms of service, because you know I do play nice.
Don't destroy any satellites on the way, right?
Well, you know, I did that satellite orbital system last year, so not that, you know, that project didn't last more than 2 hours, but I built an entire satellite orbital management tool, and then the guy's like, "No, this is bullshit. There's absolutely no way this is going to work." And I got an email from him the next day. It's like, our team is dumbfounded. You managed to do it in 45 minutes, what we couldn't do in 2 years. So that was and this is from some big giant aerospace company that basically called me up on a whim. So I do have at least one suborbital management system in place. Turns out suborbital management of a constellation of satellites is almost exactly like managing any kind of mesh-based swarm. The only difference is they're floating around in the outer reaches of the atmosphere, but their communication mechanisms, the sort of sparseness of how they need to communicate, because you don't have a whole lot of electricity, you want to limit sort of, you know, the communication unless absolutely required. It was like basically Claude Flow in space, which is fun.
I love it. You got some chops there.
Yeah, it's just so many crazy projects at this point. It's like the 12-year-old version of me. It's like is very proud. It's like living my cyberpunk. This is exactly what I thought 2026 would be like. Maybe a few more robots. I thought it would be, or flying cars, but generally speaking, it's happening. Yeah.
The wheel ain't got nothing on AI.
We'll see. I think at some point, I would guess at some point, the rest of the AI world is going to clue into sort of, yeah, what like what do we call our style of sort of, you know, GPU-less self-learning vectorized attention, like what should we call it? It's not like traditional AI. I think we need like a name for it, like a
I think
category.
the GPU less is a very intriguing angle of it, right? Because
But
that's not what people expect.
How do we say that without saying, I don't want to sound diminutive. Like I don't GPU less sounds like it's less than. But it's actually
CPU centric then.
But it's not CPU centric either. It's more of this kind of concept of like it's playing on the weird quirks of kind of temporal dynamics, which sounds like Star Trek, and then using sort of this idea of a strange loop that can go and use these tight little wound sort of logic bombs collectively to solve and learn.
Yeah, you can't use that.
That's what it is. That's what it is. But we can't call it that. I
can
need
use that.
Oh,
but not yet.
It's Chowderbot. Yeah, Chowderbot. That's what it has to be called. You know, something stupid that goes viral, right? Anyways, that's the problem. But figuring out the thing. Not that do we even care? I don't know. Maybe we just call it agentics.
Yeah, it's a bit conflated. There's too much. It's too big a cloud. You need something specific, like a way to slice through the noise.
Oh, the thing finished. Look at that. You're just in time. All right, so we're done. All deep agents ADRs are complete. All but okay. It's probably gonna have some bugs. Build, run, and check logs for errors. Do complete. I'm gonna start with complete review.
Call it reflexive.
And what's that? Reflexive.
Reflexive or tidal, microgenic, Lupus AI.
Yeah, I like anything with an R.
It's almost like the smallest possible unit of LLM usefulness. So I wonder if it's not something akin to atomic LLM.
You can do like auto poetic too, which is like self-creating systems that bootstrap themselves through recursive internal dynamics.
Yeah, that's back in the nerd territory. People want Chatterbot. They don't want they don't want it, they don't want to know what it is. They want to know they want something that they can talk about on TikTok.
Title? It's
Well,
it means like temporal rhythms,
well,
feedback loops and flows.
Or maybe then
I'm just shooting from the hip here. So
yeah, no. I did that pack thing there a couple of years ago, where it's like defining the structure of like the taxonomy of something that learns and is proactive and all that kind of stuff.
I do inactive, even though I don't really like that word, but
inactive.
Similar to what we're doing. Yeah, inactive. So from cognitive science, cognition emerges through dynamic interactions, not static representation or temporal dynamics in a word.
Temporal AI.
Thumbs up, but
it's what it is. It's actually if you think of it, basically be time bounded AI. Like when you it's or for Colby, we can call it the golem. Golem?
Yeah, I asked you because I had no clue what it was, and you're like, I have no clue what it is either. I'm like,
although now that I've been doing all the work on that Mac Mini, using the Colby school of Mac Mini nuclear mode, I see golems all the time. I think it's
I know. Yeah, it's crazy. Like,
yeah.
By the way, I discovered the Mac totally by accident because my 2 Windows servers were busy when Rue was having me do the simulation. Like, I just had that Mac sitting there. I was like, I guess I'll use that. Like, I'm glad we found it. I'm glad everybody's getting on it too. It's amazing to develop on it with this stuff. To be completely honest.
By the way, Colby totally inspired the Mac purchase. By the way, and he was dead on. And I was watching him do his like crazy nuclear mode or whatever it is you were dreaming up. I'm like, oh man, I need to do that.
Yeah, I wrote I put 18 shaders, 7 kernels on my own GPU server.
What persuaded me on the Mac on the end was the fact that RAM's really expensive, but the Mac has integrated RAM between GPU and CPU.
Unified. Yep.
Yeah, that's
the VRAM and the GPU cores combine, and you can go right to the metal.
And if you have the courage, you can install the Groove Optimizer, which will optimize the VRAM on the Mac. Now,
did you get my message about that though? I'm not 100% about what I sent you, but it was saying some stuff about the Mac.
Like, wait, what do you mean?
I sent it to you in a private chat. I was like trying to figure out exactly what it would do and optimize, and it was telling me like that it doesn't work. I'm not saying that not the whole thing, just like some of the caching and stuff because it's different. I was just curious if like it's wrong. It's wrong what it told me, and you know something different. I was just curious.
I don't know. This is the one from the yesterday's release.
Yeah, the Mac you released. I was trying to like understand how it worked, and it was saying that you can just read my private message. It's not like a bad message. It's just
make sure you're using the most recent version for sure.
Okay.
I don't know. I did performance testing and I saw a significant improvement.
Yeah, if it's working for you, great.
The question is, will it work for anyone else? Who knows?
It works on Windows. I'll tell you that much.
Yeah, Windows is spectacular. Like
Windows is totally different architecture. It crushes on Windows. It's amazing.
Yeah, I can take an old freaking Windows computer from and we were talking about that on a call the other day. Like I got RuVector working on an emulator anyway on a Commodore 64. I can optimize like old computers from like the 1990s, Pentium 1 class computers, all kinds of stuff. It's actually quite amazing what you can do on the sort of PC side.
So what about on a Linux machine, in particular on a Linux host like Proxmox?
Well, I've already doing that. I've been doing that forever. Like the optimizing for Linux. Okay. Yeah, the system already optimized for Linux. I build everything on Linux, right? So I didn't really need to do much. Now, I think what you're probably asking is, have I published my Linux system optimizer? No, but I probably should. But my Linux optimizer is specifically built for my my chip development process. So I don't think I can probably make that available in its current form. I can't give away all my stuff, guys. Like, guys gotta make a living.
Come on, you told me to give my secrets away. Give them away, Rue.
Well, Well, you know, the chip industry, it loves intellectual property. So, you know.
I know. I made that drawing when we were on that call that day, and you're like, put it away, put it away, put it away.
Yeah, well, here. Well, there's a difference between you give away nothing. I give away 99.9%. I keep that.
You do. I haven't gotten comfortable with it yet. You're like Mother Teresa, and I'm from like corporate America. I'm trying to get there. Okay. I got a few things I'm releasing.
So just cut off the bit that would be useful for generic Linux crap.
Yeah. So so what I built for Mac specifically, assuming it works, would be relatively simple to port to Linux. Architecturally, they're almost the same.
Yeah.
So I think Macs are like loosely based on like BSD or something, Core or some kind of something like that. And that's, you know, Unix, Linux kind of differences, but
we have a lot of WSL people on here. They use WSL.
They use it. Yeah.
I don't use it anymore, but I like, you know, I always mistakenly make stuff. I actually wrote a program that I'm happy to give to the group that allows you to do the computer control and voice that runs off the Linux. And somehow I built some way that you can talk into the mic in the Windows machine and it reads up to the 4K monitors perfectly. Like,
Nice.
you know, you can't do that with WSL. It's like supposed to be impossible, which I didn't know, but mine works. I don't use it.
You know, this is a good opportunity for you. Why don't you do a PR on my optimizer and we can collab on that. If you add the
It's
WSL
the connection it's the connection getting the mic and the monitor to work through WSL because they're different, like they're different operating systems. So you're like, you have it running on Linux, right? That like with Google or whatever, when you're talking to it and it's talking back to you doing OCR, right? And it can control your screen too with the mouse. It's just, there's nothing out there that allows you to do that with WSL and Windows because of how the architecture is. But I got it to work.
Sounds pretty cool. And we'll do the
help me release it. It helps everybody.
Yeah, do it. That sounds awesome. All right, I'm gonna have to take a quick break for my next call. Thanks everyone. And I will
see you later.
I'll publish this new updated Windows version with all the bells and whistles and the Colby nuclear mode here probably, I don't know, day or so.
Yeah, nuclear mode. I love it.
True.
All right. Tomorrow, 12 o'clock Eastern, the AI Hackerspace for those who are interested. If you want to show anything, you know, feel free. That's your time to shine. All right. And for those who are, for those coming out to Bangalore next week, I'll see you around. I'm not around next week either, by the way. So if you guys want to do this, then Martin and Rob and whoever, you guys need to figure out how to get that going. But you should be pretty good.
So I got a week to get ahead of you. Cool.
Yeah, there you go.
We already agreed with Rob that Helsinki is going to host a Friday, and we will have a pretty decent show on Friday.
Live from Helsinki next Friday is what we're thinking.
Oh man, well, without me around, oh, okay.
Fly safe and good luck.
We will save it to the story for you so you can watch it later. So.
All right.